All right, so yesterday we learned about parallelograms. We learned different properties of parallelograms. Let's review those super quick. The opposite sides are parallel and congruent. The opposite angles are congruent. Consecutive angles, which means the angles that are side by side, the orange one and the green one, you add those together and they would equal 180 degrees. And then number 5, the diagonals bisect each other. So today what we're going to do is we're going to learn what some properties or how we can use these properties if we have a parallelogram on a coordinate plane. So our first problem, we have 3 vertices and we have to find the missing vertices. We have to find that missing vertex. So the first thing you're going to do is you're going to graph these problems. Remember that the first number is the x coordinate, the second is the y coordinate. We always start with the x. So I'm going to graph point J. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8. So there is J. It is at 3, -8. K is at -2, 2. 1, 2, 1, 2. L is at 2, 6. So there's L. So when I connect these dots to make a parallelogram, I can see that this would kind of come down like this, and this would kind of come up like that. So I've got a general idea that my missing point is over here somewhere. All right, I got a general idea. However, I want it to be precise as possible. So I'm going to use the fact that the opposite sides are parallel to find that missing point. What is special about lines being parallel? Do you remember? They move in the same direction. They never touch. If they move in the same direction, that means that parallel lines have the same slope. So that means that the slope of KL would be the same as JM. Wherever that M is, it's going to be the same slope. So let's figure out what the slope of KL is. So I'm going to go up and over. Okay, so let's count my slope. 1, 2, 3, 4. So I went up 4, and then I went to the right. 1, 2, 3, 4. 4. So my slope from J to M is going to move the same distance. So 1, 2, 3, 4. 1, 2, 3, 4. So right here would be my point M. So I was close, right? I was in the ballpark. I was in that area. So here's M. Now I've got to state what that point, what that coordinate name is for point M. So that means this is where you'll make your mistake. Instead of writing the name of that point, you'll write the numbers that you used for your slope. You'll say it was 4, 4. And when we actually graph 4, 4, it would be way up here. And that's definitely not point M. And that wouldn't even make the parallelogram. So we're going to put that point. We're going to start back at the origin and count over and down. So 1, 2, 3. So I'm going over 7. And then I've got to go down 4. All right. So you're going to have some problems like that in IXL. I've got graph paper if you guys need it. I'll be glad to share with you. All right, so now we're going to talk about the intersection of the diagonals. So we want the coordinates of the intersection. So let's graph our problem. Go back to my blue ink. So A is 2, 5. So 1, 2, 1, 2, 3, 4, 5. There's A. B is 6, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. C is 4, 0. 1, 2, 3, 4, and I don't go up. And then D is 0, 1, negative 1. So 0, negative 1. That's D, that's C. So let me double check these. 1, 2, 1, 2, 3, 4, 5. 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, and I don't go up. And then don't move and go down 1. Okay. So here's my parallelogram. So the diagonals would be from B to D, and they would be from A to C. So right here in this center, that's my diagonal. And what would that point be? 1, 2, 3, but it's over a little past 3, and it's up a little past 2. So it's close to 3, 2. However, I want it to be exact. I want to know the exact number. Okay, so let's do some thinking here. Diagonals bisect each other. That means that that intersection point is halfway between BD and halfway between AC. Now, in geometry, have we learned a formula that tells me what halfway something is? Halfway. Halfway means I'm in the middle. Right, we learned midpoint formula. Oh my goodness, Miss Bearden, that was so long ago. How do you expect me to remember the midpoint formula? Well, ladies and gentlemen, the midpoint formula is pretty simple. The midpoint formula is where you add the x's and divide by 2, you add the y's and you divide by 2, and that's the middle of your line. So, x plus x divide by 2, y plus y divide by 2. So let's see. The diagonal, and since it's the middle of both of them, you only have to do one of the lines. So, I don't know. I'm going to do this one. So I'm going to use the coordinate for A and the coordinate for C. So 2, 5, 4, 0. I'm going to say 2 plus 4 divide by 2. 5 plus 0 divide by 2. 4 plus 2 is 6 divided by 2, 5 halves. So that would equal 3, and then 5 divided by 2 would be 2.5. So this 3, 2.5 is the actual place where the diagonals intersect. That's really close to my guess of 3, 2. You're going to have some problems in IXL where you're going to have to use this midpoint formula. Some of the problems you might be okay with guessing and just spotting it by eye. Some of the problems you won't be. So that's it. We are done for today.